Hello everyone and welcome to PostgreSQL Crash Course. This is day 17 and I apologize because I could not upload the videos for last 1 week because I was keeping busy. So today I will be going to talk about the different maintenance option in PostgreSQL, and I will be discussing one in detail today. So, what is the maintenance? As a SQL DBA, we already know that what are the maintenance tasks which we can do in the database. So, database maintenance in PostgreSQL is essential to ensure the optimal performance, data integrity, and efficient storage management. And that is hold true for all the database management system, not only with the PostgreSQL. So, there are a couple of operations which we can perform, or a couple of maintenance operations which we can perform in PostgreSQL as well. So first is the vacuuming. So vacuuming is just a process to reclaim the space, and that is due to the dead tuples. And I will discuss this in detail today. What is analyzing? So analyzing is just simply in SQL Server we have update statistics. So what are statistics? So basically due to this, I mean, with the help of statistics only, the query optimizer will create a plan. So statistics just shows the information about the distribution of the data inside the database. Then we have reindexing. So reindexing, as we know that it rebuilds all the, in case of PostgreSQL, it rebuilds all the bloated or corrupted indexes. Okay. Then we have backup and recovery. We have already seen detail about this backup and recovery. Oh, sorry, before that we have integrity checks as well. So yeah, definitely we can do the integrity checks in this. PostgreSQL backup and recovery is the next one, which we have already discussed. Monitoring and logging, we have a couple of tools like pgstat statements, pgstat activity that you can run to monitor, and you can also log the different things in PostgreSQL. And log file maintenance, this also we have seen that how we can rotate the logs to avoid the disk load, and how we can do how we can monitor the slow queries, errors, and auto vacuum activity. So this will come under this log file maintenance. Then we have security and user management and the configuration tuning. So in today's video, we are going to learn about the vacuuming in detail, and maybe in the later videos, I'll go through other aspect of database maintenance. So in case of a vacuum, what is vacuum? So as if you remember, we have discussed about the theories about PostgreSQL. We were discussing about the MVCC, multi-version concurrency control. So PostgreSQL have multiple version of the same data. So whenever you are going to delete or update any row, it is not going to update or delete immediately. So what it does, it basically create a new version of that particular data or particular row, and it will keep those deleted or updated row in the table itself. And when there are a lot of DML or like update, insert, or delete operation on those tables or on that data, all those data will be uh, you know called obsolete data because it is the old data. And these obsolete data will consume the disk space as well, because it is data, right? So it consumes the data blocks. So over the time, when there are too many DML operations, the table becomes bloated. So when there are a lot of dead tuples in the table, those tables are called the bloated tables. So by using the process called vacuuming, we remove those obsolete rows or those dead tuples, and we reclaim space. As well as if we use vacuuming with some option called analyze, it will also update the statistics, and that statistics will be used by the query planner. So in case of PostgreSQL, we have three kind of vacuuming. One will be the standard vacuuming or normal vacuuming. So it will basically reclaims storage by marking the dead tuples as reusable. So you can consider this same as when we take the log backup in our SQL Server database. So what happens in the inside the log files whenever you take the backup? So all the committed transactions, those will be marked as reusable. So whenever the next transaction comes, then you can that transaction can use that particular virtual log file, right? So similarly here, in case of a standard vacuum, it will not release the space to the OS, but it will just mark those dead tuples as reusable. So next, whenever the next time data comes, it can uh, those tuples or those space can be used. So it does not shrink the physical file size. It runs faster and can be executed frequently. Okay. Second option is vacuum full. So in case of vacuum full, it will rewrites the entire table to remove the dead tuple. So when it does this vacuum full, it releases space to the OS. So it is simply, you can say, you can just compare it with the SQL Server feature called shrinking. When you shrink the log file, it will it will reshuffle the pages, or it will reshuffle the VLFs, and it will release the space to the OS. And in similarly in vacuum full, it does the same thing. And during this, as it is rewriting the entire table, it will log the whole table. And the other option is auto vacuum. So PostgreSQL has a built-in auto vacuum daemon. It automatically runs vacuum and analyze in the background, and it gets triggers based on the threshold. Okay, so this is the short information about small information about the vacuuming. So why we need vacuuming? So vacuuming process improves performance by reducing the bloating on the tables, right? You understand what is bloating now, right? Bloating means whenever there are a lot of DML activities are happening on any table, that those deleted or updated rows will be there in the table, and those tables will be called the bloated table if we have multiple dead tuples in the table. So another job of vacuuming is it keeps query planner statistics up to date if we run with analyze option. So as we know that what is the statistics, it will basically help to create the plan. If the statistics are stale and if it is not updated, query optimizer will create a plan that is not suitable, and that will be not be the best plan. Third, it recovers or reuse the disk space occupied by the updated or deleted row, right? So we have seen that in case of a standard vacuum, it will release the space. It will not release the space, but it will make the space reusable. And in case of vacuum full, it will reclaim the space to the OS. It protects against the loss of very old data due to transaction ID wraparound or multi-exact ID wraparound. So this thing maybe I'll try to cover when I will do a vacuum freeze. So uh, this is the theory part, and now we'll move to the practical or demo. So for this demo, let me first check if our server is started. Okay, it is already running. Now what I will do, I will go inside our PostgreSQL cluster. Okay, now we'll see we have multiple tables. So we are going to create one table here. So we are going to create a table called demo. So it is create table demo. This will be one column string, CPU and memory. There are three different columns. And now before doing that, what I will do, I will alter this alter table demo set auto vacuum enabled as false, because our auto vacuum is enabled by default. So now I have set it as false just to show you how auto vacuum works. Now what I will do, I will just insert few rows in the table, and those will be the dummy rows. Okay, so insert into demo, select. This is the text which I will insert here. So now I can first let me see if the table is created. Yes, table is created. Now I can see select count star from demo, and I will see this is having 10,000 rows, right? And if I want to see the size of the table, there is a command it which we are already using, plus table name. It will give the information about the size. So it is 616 KB in size of this demo table. Now what I will do, I will delete few rows from this demo table just to show you how this vacuuming is helpful. So I will delete from demo where CPU is less than 40. Okay. So now it is saying it has deleted 3,944 rows. Okay. Now I will enable the extended display by this command, and I will just run a command called select star from pd underscore stack underscore user underscore table. So this will give information about the table, and this rel means relation name equal to, we'll give the name as demo. Sorry. Okay. So now we can see here that here the tuples are 10,000. It was earlier, and we have deleted this 3,944 rows from here, and here it is showing as just a minute. Okay. Yeah, so here it is showing as 10,000 tuples, and we have deleted this, and it is showing as live tuple as 36056, right? And dead tuple as 3099. And it is saying mod since analyze 13,944, and uh, this is since vacuum 10,000. Okay, just please make a note of this one. We will come to it later. Okay, so we have already seen that select count star from demo is, sorry, we have to turn off the display. It is 6,056. Now, if I will run a command called explain, so explain is just to show you how analyzer will look into the table. Select star from demo. Okay. So here you can see the total count of the actual table is 6,056. But if we running this explain query, it is seeing, or it is considering these tables at 7,326. And again, this is due to the bloated tables which we have just deleted, but those tables are still present in there, right? So what we can do. Okay, so yeah, here we have we can see like we have dead tuples. Okay, now what I will do, I will just run this command that we have already executed earlier. So 616 KB. Earlier also it was 616 KB. So you can see the storage is still the same even if we have deleted the rows, right? Because we haven't done the vacuuming, and we have disabled the vacuuming. We have turned off the vacuuming for this particular table. Now what we will do, we will just run the vacuum for this table. So command is vacuum vacuum. We'll run the full vacuum with analyze ANALYCE and verbose, and the table name will be demo. Okay, so once we have executed, it is showing couple of the statements. And now what I will do, I will again go and I will run the same command here. Oh, sorry, we have to enable this display. See. Now you can see here they are saying that a tuple deleted is 3944 and live tuple is 6056, and here they are saying 10,000 rows since vacuum, right? So now if you see earlier example, here it is saying tuple is 3944, and here dead tuple was also showing 3944, right? But here if you see there are no dead tuples, right? There are only tuples which are active at present. And if I will go here and if I will show you the size of the table, now you can see this is a 360 KB file, right? Earlier it was 616 KB. So you can see by this example that the by using the vacuuming, by doing the vacuuming, we have reduced the size of the table, and even now they are here we can see just one more thing. If I will run here command called select count star from demo, we can see we have 6096 rows. And now if I will run the explain command again, earlier it was showing the incorrect value, and now if I see it is showing the exact rows. So if the rows are not correct ones, so again that query optimizer will create a plan that is not suitable for that particular database or tables, right? But here as we see now the tables has the same rows in optimizer as well, and optimizer is considering the same number of rows which is actually present. So this is how we just vacuum how the vacuum operation works. So we have disabled the vacuum for this, so we will just enable the vacuuming again for this particular table. Okay, it is enabled. We can also see there are different options with the vacuum. So command is vacuum db hyphen hyphen help. So if you want to use this vacuum db command, you can use this with different options, right? Hyphen a means all, hyphen db with the db name you can use, hyphen f is freeze. I will show a couple of options later as well. But for now, for example, if we want to vacuum our database called Postgres, so what we will run, vac vacuum hyphen u. We will give the name as Postgres. This is the username, and then we will give the database name as Postgres. Sorry, my bad. It is vacuum DB. Just a movie. I think I have misspelled something. Yeah, this is the right spelling. Okay, it is asking for the password. So you can see that it has done the vacuuming, and if we want to see the messages as well, we can now have the option called verbose. So it will show all the messages what it is doing in the background, right? So this is how we just do the vacuuming, and this is it for today. And I will show different other options for the maintenance of the databases uh, in the Postgres in our next session. So till then, take care. Thank you so much. Bye bye.